Once you understand the way broadly, you can see it in all things. Miyamoto Musashi, The Book of Five Rings. Teaching a man to fish instead of handing him a fish may be a noble endeavor, but not if you're handing him a baited hook to use. First, we need to know how to properly bait a hook, but not all fish eat the same food. So we need to know the fish we're trying to catch before we know what bait to use. Different baits are hooked differently. Fishing can get really complicated when you think about it. Teaching a man to fish can get even more complicated if understanding gear ratios in the reel are important factors in the catch. In the analogy between fishing and compositing images, knowing gear ratios of the reel is just as important as knowing which bait to use or how to hook it. It's not enough to combine images at random or even match horizons between respective images. Compositing is more akin to drawing and painting than photography. Focal lengths and distances from objects matter if the composite is to be seen as representing reality in the slightest. Proportions between objects in a scene matter. The visual compression, the projection and warping, all these things make a difference. Simply removing an object from its scene and replacing the background is not considered compositing. The intention is to make an image that appears to be plausible, even if in a fantasy world. I say all that to stress the point that teaching a man to fish isn't as easy as explaining the idea of how a fishing rod is used to catch a fish. This may be the first step, but an absolute rudimentary one. There are so many components that go into composite work that a quick tutorial on how to find the horizon in an image with no discernible one becomes almost impossible without assuming a certain level of knowledge. After all, just because the horizon can be found doesn't mean your composite is going to look right or have been done correctly or represent reality in a convincing manner. Having said all of that, I'm going to show one technique that I use to find the horizon where one isn't apparent. The thing about what I just said is that doesn't mean the horizon we find is the real horizon of the Earth, unless we assume our measurement reference is level. Understanding this technique really requires a working knowledge of the theory of relativity, as well as perspective drawing, plane geometry, and parallax. If you need a refresher course on any of these, they will go a long way to refining the skill of compositing. Matching lighting conditions and atmosphere, shadow density and color temperature, focal lengths and proportions, all are equally important considerations in a convincing composite. But I digress. This technique is one of many, I'm sure, and will get extremely complicated depending on the way it's used and the image it's used on. In our first easy examples, we can see where the model touches the ground. Without that, a lot of assumptions have to be made with regard to how the model is posed in relation to the floor, such as if their eyes are the same distance from the floor or which direction their head's turned. Things get complicated. And there are tools in Photoshop that allow for inaccuracies to be corrected, but that's a separate issue. So let's jump into Photoshop and get started. We got this picture of Lucy here. And what we know about reality right now is she's touching the ground. So the trick is if you can identify contact points on the ground, we can draw an ellipse. We can draw an ellipse to figure out what the ground plane, how it's pitched, and how this ground plane is pitched is going to determine where the horizon is. So let's back up here. All right, so I got some guides drawn in here. And what we know is this is center frame, and this is where the camera is pointing. And it's also the horizon if the camera is level. But we can't tell if the camera is level or not. So we're going to figure all that out by the pitch of the ground. Now how we're going to do that, we're going to take our line tool. Let's make it a red color. And let's just draw a line between these contact points. Let's go with the tip right there. And let's come over here to this one. And let's extend it out to the center, is at the center of the frame. This is kind of crucial because this is creating an access point between going into the frame and coming out of the frame, if you can think of it that way, but let's not get too complicated. Make this line a little bit thicker so we can see it. All right, let's duplicate that one, and then we're going to flip it horizontally, because what this does is it in 3D space, it makes these angles 90 degrees. All four of these angles are 90 degrees. So if you drew a circle around this, or if you draw an ellipse around this, it will be a circle in 3D space, which is actually, it would appear to be a pitched disc. So let's get our selection tool and get our elliptical marquee. Let's create another layer. And I'm just going to alt click and drag out until I get to where they're going to all touch. Okay. Now I'm going to take my paint bucket tool and I'm going to fill that area. And I'm going to drop the opacity down so we can kind of see here. I'm going to zoom out. Now, does it appear that she's standing on that disc? Of course, I could mask her feet out a little bit, but I'm not going to do that. We're just going to kind of look here. That looks pretty good. So if you see how that kind of works there, what we've done is created a focal plane. All right, so to keep it kind of simple, this is kind of how you do it, and then I'll kind of explain it as we go. All right, so I've grabbed all these layers and I've moved them all down to the very bottom where this axis point is at the very bottom of the frame. Okay. So now what I'm going to do is I'm going to take my line tool and I'm going to mark the horizon. Well, I'm going to mark the center frame. It's not necessarily the horizon. Okay, then I'm going to grab all these layers again and I'm going to move them back to where they were, which was right there. All right, so this line is real tiny. You can't hardly see it, so let's make it bigger. And there it is. So that is the horizon. The camera's pointing here, but that's eye level. So this may not mean a whole lot to you right now as you're looking at this, but if I get rid of these guides, so this is now the horizon, and the center of the frame is here. So that's where the camera's pointing, but level is here. So what you can tell is happening is the camera's up, but pointing down. Okay. So to show this, let's zoom out here. And I'm going to go up here to my canvas size adjustment. And I want to make it wider so I can see how she kind of sits in here. So let's change the width. I'm going to multiply by 5 and slide it that direction. And then I'm going to make it taller so that we can see the center of the frame, but also the horizon. So let's multiply that by 2 as well. So it's going to expand up and down and out to this side. And she's still in the middle, and we still got guides. All right, let's drag another guide down here to what is our horizon. And if we want to show and designate some of this, let's make a layer to write some notes on. All right, let's come in here and identify some of this stuff. And here is where the camera's pointing. We'll call this center frame. Okay, so like I said before, the camera's up and pointing down. So let's take our line tool again, and one of our original lines, let's pick the other one. We're going to drag it out until it crosses our horizon. Okay, and then we're going to drag a guide over to mark where it crosses our horizon. All right, let's go down here and create a new layer so we can make a background. Got my paint bucket tool. Let's fill that with white. Let's take our line tool again, select our horizon. Let's drag it out so we can turn these guides off. So you can kind of see what's going on. Proving some of this stuff, let's take our line tool and let's pull out from here and look at how our eyes are laying. So our eyes are laying right on target with that line. And down here, this line cuts right across the fabric of her ankle. Looks like it would penetrate her knee bone if her knee was cocked up right, but you can see some of these lines in the dress match up. And if we drop one right here and zoom in and look how that compares to her shirt line, I mean, that's almost perfect. So does this technique work? Okay. Obviously, this is the center of the frame. This is where the camera's pointing. This is my horizon, and I'm pulling my vanishing point lines from that vanishing point, and they're lining up. So that's pretty good evidence. But to see the mechanics of the camera, let's take our line tool and let's pull one from here to our center point. That's where the camera's pointing. And we can take that line and we can duplicate it. And if we rotate it 90 degrees, it is at 92.49 degrees. So that means that this other line is 177.51 degrees. So let's pull up our calculator, because I don't want to do no math in my head, and I want you to understand how this got to the point that it's at. So we have 177.51 degrees, and we know that 180 degrees is flat. So let's take 180, 177.51. So the camera is tilted down 2.49 degrees. Now, if you don't know the focal length, then you're just going to have to slide the camera back and forth and hope for the best. So if I do this to a couple more images and we look at how they differ from each other. So this is one that I did where she's standing on the ground and her feet's apart. We can raise this up so you can kind of look and see. So, and I used the same procedure I drew on the floor, except the contact points that I used were just all along this edge. So I'm just drawing a straight line between here and here, and then doing that same process. And, you know, remember that you have to split the center of the frame. But anyway, so let's move this back down here and put her back on the horizon. Of course, she's scaled up. I could scale her down. If I wanted to scale her down, I can drag this point either to the vanishing point or somewhere along the horizon. Let's drag it to the vanishing point. Okay, so we got her. We got her lined up on the horizon. And here's another her. Drop the opacity. Same deal. That was the image we just worked on. There's the center frame. There's the camera tilt. There's the horizon. She was at 50 millimeters. And let's bring that one back up. Turn the opacity back on. And let's just slide her over here to where her vanishing point lines up. Okay, let's take both of these and then drag them over and put the vanishing point over here. Okay. So now let's turn this other one on, and we can see that I didn't really use that technique. I used this technique. I just pulled a line between her two toes and ran it out. And it turns out that I was pretty sure that her eyes and her feet are parallel. So this is the trick with knowing that maybe parallel lines are not very apparent, but they still exist because of the way the body is shaped. But as you can see, most of the things are kind of lining up, so it's probably correct. Her hips, the tops of her, that's not her. Her knees, her ankles. So that's the technique. Now, if I wanted to make this a world, then I could use all these perspective lines, and I could make a floor for her, and a floor for her, and a floor for her, and I could intertwine those in real 3D space if I wanted to. But what you'll notice is it's kind of hard to combine these focal lengths, because what if she was standing here at 50 millimeter and then she walked up here and I took a picture of her, she would not look like this at 50 millimeters standing this close. This is what she looks like at 52 millimeter. And even though it's not a discernible difference, as you can see, the camera is pointing here and the horizon is here, and now the horizon is here. So the camera's higher, so her feet will look different. You can't get her feet to line up, to be on the same plane. Even if I scale her down, it's still a lot to overcome. If I try to get her down around the same size, that's pretty close. And you can kind of see that her feet, it's just not, she's not really standing on the same plane. Even if I, especially when I put her horizon on, she would not be standing out in front of her. She would be standing below her. If you put some steps here, that would be a little bit more accurate. However, That's way more accurate. Of course, we can move our registration point up here on the horizon and scale her down. Now, is she proportioned? It really all depends on where you're trying to put her. Same way with any of these. If she was standing on a box that was closer and higher, it would appear right if she's standing on a box that's down and a little bit further away. So the really important part in proportioning is to identify something within the scene you're trying to composite that gives you a size relationship between people. Like, say, if I put her in a room and that room has baseboard, I know that the baseboard is probably somewhere around here tall. So if I scale her down and move her over near some baseboard and scale her down to her foot's about the size of the baseboard is, then I know that she's in proportion to that spot. Now, if you try to put her on the correct horizon and it don't work, then the focal length is way off. That's really the problem there. But let's move along and try this other image. Just kind of take a look here at what's going on. And in this image, I kind of done the same thing but reverse, because you can see you can't see her feet. So here's the picture. This blue line is the center frame, so that's where the camera's pointing. And this is my horizon. What I've done here is I've used her eyes that are straight across from each other, and I've made a focal plane that's a disc that's pitched down. And then I've done all the normal routine to figure out where the horizon was. But this is an illustration of where, if when I moved this point up here, I replicated this disc on the bottom so that this one is pitched up, this one is pitched down, so that when it's really a cross section of a cylinder. And as you can see, the camera is pointing at the center frame, and then your field of view is here, from here to here, and then it's looking at that disc at that angle, which the mirror opposite would be down here out of frame. Now, this is a lot to explain, and that's why it's kind of took me so long to get to this point, to show you the easiest way I knew how to find the horizon in an image with no apparent horizon. But it definitely does not work in this image. This is a little bit weird. You think maybe we can use these lines, but these lines will just tell you where they converge in infinity, because this is a hallway that is sloped downhill away from the camera. So this is a ramp, and level is actually up here somewhere, not down here where these lines converge. So this image defies logic in a sense. Even following all these lines, the vanishing point it appears somewhere in here, but the way he is standing and the way his feet are, they kind of show the gravity once you start doing the math. But we could do this picture of Anna, and what I would do here is I would use her foot and then make me a circle, and her horizon is somewhere around in here. And when you do the math and you expand the canvas and get her situated, it looks like that's where the horizon should be. So this technique works really good, but it is a beast to explain. If you have any questions, or if there's anything that I kind of didn't really, or glanced over too fast, let me know, and I can go like specialized on one specific thing, maybe to help get you past it or whatever. But in the meantime, brother, good luck, and I hope this helped, man.